you probably remember this sort of set of meetings started out as a satellite meeting in the 2018 HUPO Congress down in Adelaide. And Ralph and I have been amazed by the community, the level of community engagement and support from all of you for these meetings. So we've kept on doing them on a roughly annual basis ever since. So they're in an association with the Australasian Proteomics Society and the Australia-New Zealand Mass Spec Society. And so we oscillate between a kind of a satellites. Obviously, this one's in the run-up to the Lawn meeting starting on Thursday. So as I briefly mentioned, this is our largest ever meeting. We've got well over 60 registrants now. We've got from at least 25 different institutions and probably more kind of core facilities than that. It's always hard to sometimes tease out how many core facilities there are at each university. But yeah, we've got a really broad spread of people, and we're really looking forward to your engagement in this process. So as we've done in previous meetings, there will be breakout sessions and jam boards where we're really trying to garner your input into this. And even though it's all an online and virtual format, we've got it structured so that we can really have a fun afternoon or a fun few hours discussing some interesting topics. So we've got 3 sessions. We're gonna, if we manage to stick to time, there'll be 10-minute breaks between each session so we can check what emergencies are happening in the lab and put out any local fires that are broken out. But hopefully we're going to try and stay on schedule. Session 1 is the multi-center testing initiative. This was a big program that was run last year, and I am on absolute tenterhooks trying to find out the results. I've been nagging Ralph all week trying to get a pre-glimpse, but he's been very mean and not shared barely anything. So I'm super excited for that session. And then in our second session, we're going to have a look at the, as I always like, provoke controversy, the divide between the professional staff and the academic staff. And we're going to look at how that kind of categorization of people can impact the way we do our jobs. And interestingly, we asked you those few questions whilst people registered. And we have a near perfect 50-50 balance between people who are in an academic job description and people in a professional staff job description, with a slim 5% of you who are the square pegs in the round holes, who are in a categorization that doesn't fit between those two pigeonholes. And then lastly, we're going to wrap up with a quick overview of the 2020 survey. So without any further ado, I'm going to hand over to Ralph, who's going to chair our first session. Ralph.
Well, thanks, Ben. I mean, I can only echo what Ben just said. I mean, it's absolutely fantastic to see such a turnout here. And, I mean, we're already at 50 participants, so 10 are still missing, but it's fantastic that, everybody seems to be interested in what we're doing and, get a little bit community going between the different mass spec core facilities. So let me just share my screen for the presentation. Hopefully that works. Ben already covered nicely the program, so I don't have to talk about that. Do you see that, or am I sharing the wrong screen? Is it good? Oh, good. All right. So look, as Ben said, let's jump straight into session 1, multi-center testing initiative, which has been a really big thing last year, for everyone involved. So just to give you a little bit of an outline of what's going to happen in the next hour or so. So we have 3 speakers. I'm one of those. I will talk a little bit about, for those who don't know, because just based on the names, we have quite a few new people attending this meeting, just giving you an introduction outline of actually what this multi-center testing initiative is, and especially this study 1. And then both Urban and Pepe are going to talk about the results. So Urban from our lab, he's going to focus a little bit on the metadata analysis. So how many participants did we get? How many data sets did we collect? Which mass specs have been used? So all around metadata analysis. And then Pepe from Mass Dynamics, he's going to talk about, the long-awaited results. And he will also share, or he will showcase the website, which we are planning on sharing with all the participants, probably after launch, so next week, that everybody gets access to their data and can browse, the results and comparisons to others. And after we have, more these formal talks, then we, as Ben said, we're going to have as usual, our breakout groups where we would like to get some feedback from all of you, how this goes, where we should go next, and so on and so forth. But look, let me just really, I try to be really quick because we covered this in the last meeting. But so what is this multi-center testing initiative? And look, so the whole thing, I guess, was sparked, I mean, meanwhile, 1.5 years ago, where we realized that, probably just where Australia and New Zealand is located geographically, normally the core facilities are not really included into any benchmarking exercise, which are routinely run in Europe and the US. So we just wanted to have sort of like our own benchmarking exercise across the different mass spectrometric core facilities, with the overarching goal to examine reproducibility across the participating facilities. And I mean, the idea is, is with, sorry, just a second. Yeah, so I mean, the idea with all benchmarking exercises, and also this one, by the way, is, it's like samples are being centrally prepared. So we have sent identical samples out to the participating facilities. And really the aim of this initiative was like, we wanted to give every participant the opportunity to evaluate their in-house workflows in comparison to others, right? I mean, let me again drive this point home. This was not like who identifies the most proteins, but it's more like, where do I sit on the spectrum and how can I change my methods sort of like to improve the results? And of course, we also wanted to identify optimal strategies and workflows for certain, for certain sample types. And so the first study we've done, and hopefully many more studies will follow, we focused on data-dependent acquisition mass spectrometry, or shotgun proteomics. And yeah, so what we've done last year, and I mean, many of you probably know this slide, but I just wanna walk you through what has been done. So pretty much exactly a year ago, we have sent out some information package of what we envision this multi-center testing initiative to be, and whether people would be interested in joining. And a big shout out here to Matt Padula, who managed all the registrations. And after we knew how many platforms would participate in this multi-center testing initiative, we took it on to prepare our samples. So in this case, it was Urban from my lab who prepared all the samples. I'm going to talk about the samples, because nobody knows so far what exactly these samples were. So I will disclose this in a few more slides. But we prepared these samples centrally at Monash, and then shipped them to the participating facilities. You acquired the samples on your mass specs. Again, we gave you a few instructions. I'm going to talk about that. But after everybody, sort of like acquired the samples on the mass spec, the mandatory part of this initiative was like, please send us the raw files alongside any metadata, just where we captured information of which mass specs have you used, which columns have you used, and so on and so forth. And we also made it not mandatory, but optional. So we also said, look, if you want, you can use your own bioinformatic pipeline to analyze the data. And we also provided Excel files that capture these bioinformatic analyses. So again, here, shout out to Tara and Belinda, who helped a lot in creating these Excel files, which captured the metadata as well as the bioinformatic results. But one of the main things we wanted to do with this testing initiative is we wanted to keep it anonymous. So as soon as we received the raw files, Urban and I, we de-identified them, so nobody knows which data set belongs to which facility. And these de-identified raw files have been passed on to Mass Dynamics. And before I go on, let me really just say that Mass Dynamics, I think, was really instrumental in this whole testing initiative. So thanks so much for Mark, Pepe, Paula, everyone from Mass Dynamics. It was really great to see, such a support from Mass Dynamics for this initiative, and not only for the initiative, but also for the Australasian core facility in general. But anyway, so we de-identified the raw files, we sent them off to Mass Dynamics. Then Mark Condina took all the data sets, and I can tell you there were quite a few data sets, and he analyzed them all with the same bioinformatic pipeline. This was MS Fracker for those who are interested. And the results have then been compiled by Pepe. So he compiled the results and he visualized the results in a web page. And without jumping the gun or without spoiling the things, but I think this website looks absolutely amazing. And I'm really thrilled when then Pepe talks about and showcases the website, which all of you, all participants, will get full access to browse and interactively engage with their data. So we are right here. So we are We have compiled the information. We're still analyzing them to draw some conclusions out of it, but we want to share the website as soon as possible with all of you guys. And as I said, most likely it's going to happen next week after launch, when we share the URL to all the participants. So let me just briefly talk about the sample. So, like all you knew like a year ago, what was happening is that we sent out complex peptide mixtures. So it was a very simple experiment, just sample A and B. All you knew it was, as I said, complex peptide mixtures with very distinct differences. And the only ones who actually knew what was in the sample was actually myself and Erwin. So now the big revelation, so actually what were the samples we sent out to you guys? And actually, look, I mean, so the samples are, so let me go through this. So the main thing that was in these samples was pretty much human peptides. So what we've done is we ordered proteins isolated from the human cell line K562. We ordered them, I believe, from Promega. And it was actually quite an eye-opener, because suddenly, instead of working with 10 micrograms or 100, you suddenly have to work with whatever 30 milligrams. So it was was quite an eye-opener on how to process that. But anyway, but this is the base of both samples A and B. The same amount of these isolated proteins went into both samples. So what you can see here in the table, so basically every human protein that has been identified in the mass spec should have a fold change of 1. Okay, so let me get my laser pointer here. What we then also did is we spiked in a couple of proteins, and as you will see, we opted for a quite minimalistic approach for various reasons. We can discuss this later on. But essentially what we've done is we spiked in only 5 proteins into this human peptide mixture, okay? And these 5 proteins can be seen here. Some of them are from different organisms that don't share any homology whatsoever with any human proteins. There are also 2 human proteins in there which we spiked in that we know are not present in the cell line, or you can only say that it's below the threshold of detection. But so we spiked these 5 proteins in at different concentrations. The expected fold change sample B divided by sample A is shown here. We didn't go crazy with the fold change, so we didn't spike something in that has a fold change of 1,000 or something like that. So we tried to be in the range of plus minus 20-fold between A and B. So in addition to the expected fold change, so like one of the goals of this study was that we focus on quantitative accuracy. So one question we certainly asked was, how well do participants hit the fold change that is expected here? But as you will see, and also down the track when we spike in peptides, we also added different amounts of this protein. So the second question, in addition to the quantitative accuracy, was also like, can participants pick up these proteins in the first place? So this was the second question. So in addition to these 5 peptides, these 5 proteins, we also spiked in a couple of IRT peptides. So for those who do not know, so IRT peptides have been originally used for retention time alignments. And we have in our platform, we have all the 11 IRTs, which, by the way, have no homology to any naturally occurring peptide. So we have them individually synthesized in the platform. And again, so we spiked them into different concentrations into sample A and B. The expected fold changes can be shown here. And in addition to like the expected fold changes, we also added different amounts, so going down to, I think, to 40 femtomole per microliter, if you adhere to the reconstitution guidelines. So the second question, again, in addition to quantitative accuracy, is also how low can we go, and can people actually in the first place detect these peptides, and then how accurately can they quantify the peptides? So maybe we should have gone a little bit more aggressive on how low we can go with the amount, but look, this is what we spiked in, and I think it was actually a good compromise. So long story short, the sample we sent out, as I said, was very minimalistic. The expected changes are very minimalistic. The perfect data set would have been only 5 proteins should be reported as significantly different, and 10 out of the 11 IRT peptides. Okay, so these were the 2 samples. So before we sent the samples out, and again, we didn't go overboard with this, but we also did a stability test just to rule out that anything, could potentially happen during transport. Highly unlikely, because we opted, as you know, so we shipped the samples on dry ice, and we used our courier of choice, which is SFS Pharma, which is known to top up dry ice, even in transport, just in case transit takes a little bit longer. So what we've done is just a very simple experiments. We just stored the samples at 4 degrees because we thought the worst that can happen probably is people or participants reconstitute the lyophilized peptides, chuck them in the autoassembler and forget about this for a few weeks. So we just did a stability test at 4 degrees. We routinely analyzed them over a 5 weeks period. And without going into too much detail, so we looked at the protein IDs, the peptide IDs, and also the expected fold changes. And even after 5 weeks, we could see, the same protein numbers and the IRT peptides and the proteins that we spike in, the fold change was correct. So, I think this sort of like concluded that the samples seem to be pretty stable at 4 degrees, at least over a 5 weeks period. So, and as you all know, just as a recap, so, you all received the samples, including reconstitution and acquisition guidelines. And as I said, so for the first study, we focused on data-dependent acquisition, shotgun proteomics. And we essentially just said, look, use any mass spec, any LCMS hardware that you have that is capable of DDA analysis. And by all means, use any workflow and method that you have in-house. The only restrictions we applied was, as I said, we wanted to focus on DDA, only run your mass spec in DDA acquisition mode. We kept the length of the linear gradient to 2 hours. No prefractionation was allowed. And we asked participants to just perform triplicate injections of each sample. So a complete data set was actually 6 samples, just for the reason that we can do some quantification. And we also kept the amount at 2 micrograms. Most people actually went for 1 microgram or even lower, but so we kept the amount as well. And we said, please provide as many data sets as possible. So I guess most of you already know this. This was really just a very, very short summary of what we've done last year. And I'm gonna hand over to Erwin now, who's gonna share the metadata analysis. But before I do this, are there any questions so far from anyone? Okay, so Erwin, over to you.
Yep. Hey guys, my name is Erwin, and let me get the shared screen correct. Can you see my shared screen?
Yeah, perfect.
Yeah. Okay. So yes, hi everyone. My name is Erwin, and today I'll be covering the metadata of the study. So the metadata is again submitted along with the raw files to Ralph and I. And yeah, so we'll be covering the basics, the overview of the studies, the mass spec bit, and also the pre-acquisition parameters. So just before we start, I would like to tell you that this is like a very high level view of the metadata, and there are much more to be investigated. And again, just to repeat what Ralph said, the metadata will be available for someone along with the web application later by Mass Dynamics. Okay, so here's the, oops, how do I hide this? All right, so here's the MTI study. So there are 21 total number of participants and total raw data sets submitted 67, which is a good start, really, because more than 50% of the participants really data sets are actually 2 or more data sets, which means that it's really great starting point, considering that this MTI study really wants people to try to optimize their pipeline. Right. So there are 3 most obvious one here, which is P4, P11, P8, which submitted quite a few data sets, which I guess we can say that it also means that some numbers will be quite inflated due to the multiple submissions. So this is the breakdown of the mass spec by brand that you use in this study. Here we can see this chart specifically shows that Thermo really pretty much the highest at around 3/4 of the entire data sets, followed by Bruker and SciX. But when you dig in further, you can see that distribution is actually quite biased, with P4 and P11 really occupying a big chunk of the Thermo data sets. So it really makes sense to take into account multiple submissions here. To further emphasize my point, here's the distribution of all thermal instruments. So here you can see that Eclipse here has the highest data set count, but it also made up only mostly by these two participants here. So as for SciEx and Bruker, I don't really show the bias here, but these mostly centered around timsTOF Pro and TripleTOF 6600. So to see what's really going on, we decided to collapse the multiple submissions into one individual unique dataset submission. And if you see the numbers here, it doesn't really change anything, but I can show you something very important here, that here you can see Eclipse. It was previously on top in thermal instruments list, and now it's in the third. So more participants actually use HF and Explorers in this study. And for the Bruker and SciEx, it just makes the difference a little bit less significant, or more like not significant at all. So here, I just want to quickly show you the breakdown of the mass spec by ion mobility separation. So for the mass spec that uses the AMS, so obviously FAMES and TEAMS occupy the highest proportions because of the Eclipses, Explorers, and the timsTOF instruments. But here is just a mention that one Waters Synapse, I believe, uses a T-Wave IMS system. And a quick mention on FAMES compensation voltage. So apparently the primary preferred compensation voltage setting is 2. Right. So let's have a quick visit to the LC metadata. So here I want to show you that Thermo U3000 is by far the preferred LC and is connected to not only Thermo and also some of the timsTOF. Not a lot, but it is also connected there. As for the injection peptide amount, we try to cap it at 2 microgram. But again, this is an MTI study, so we encourage people to develop their own, optimize their own pipeline. So we do accept one data set that contains 4 microgram of peptides here. But of course, we see that 1 microgram is certainly the highest. But further dig in, we notice that this 0.2 microgram peptide amount in column has the most submission per participant, which means that I assume that this is primarily for the method optimization. As for loading buffer, the 0.1% here, 0.1% formic acid constitutes the majority, most popular. And you can say that these graphs still a bit confusing. There's a lot of variety here, but it really essentially means that the most commonly used is just formic acid, trifluoric acid, with or without a low concentration of ACN. This whole thing just a bit of variations, that's all. And here I try to dig in further to see whether it creates separation of some sorts, but it appears that 0.1% formic acid doesn't really, it's preferred regardless of participants or mass spec types. And here is the linear gradient used in the study. So we cap it at 120 minutes, which most of the participants really go over there. But 1/3 of the participants actually falls within 60 minutes or lower. So it's going to be interesting to find like the differences with in terms of IDs later on. This is the flow rate. So the flow rate, most of the participants here from here to here, 98% really uses nanoflows. Just a special mention to one data set, they use a 5 microliters per minute microflow pipeline. And lastly, I'm going to talk about mobile phases. So mobile phase A is quite straightforward here. 1.1% formic acid seems the way to go, at least in terms of preference. But we also shows some variations with acetonitrile and DIMSO. I think in literature, DIMSO doesn't really have anything to like affect on on tryptic peptides in like, and our MTI uses tryptic peptides, but we definitely are interested in looking at it in the web applications. So as for mobile phases B, here's just again some variations of high concentration of acetonitrile in 0.1% formic acid. There's one that is purely acetonitrile, and there's one right here. It's quite unusual, I'd say, because the concentration is quite low for mobile phase B. I'm not sure if this is a typo. I will have to reconfirm. So as in terms of this, so these graphs right here shows the final concentration of acetonitrile at the end, the very end of the linear gradient, and it can be separated into like 5 major groups, really, with 20 to 40 kind of like occupying similar preference at the top. Yeah, so I guess this is it. This will conclude my talk today. And before I hand it back to Ralph, I just want to emphasize again, this is just truly just a small snapshots of what's going on in metadata, and there's still more to be investigated. So yeah, after you, Ralph.
Well, thanks, Irvin. I mean, look, I can only echo what Irvin just said. You know, like compiling metadata for such a huge study is not that easy. I think that the take-home message here, for me at least, is like the vast majority of people use thermo instruments. So, you know, like because one of the aims is to identify, you know, like the best workflow and whatnot. So we can certainly try to do this for thermo instruments, but you know, for Bruker and Sykes instrument, the number of data sets that have been submitted is quite limited. We will nevertheless attempt it there as well. But as Irvin said, I mean, like all the metadata that is out there, and you know, we just picked a few, like, you know, column like LCs and which mass specs have been used. But all the metadata will be displayed in the web app. So I mean, once you get access to this web application, you can at your own leisure, you know, like really look through all the metadata and which combinations of LC and mass specs people are running, which columns they're using, combination with different LCs. But yes, I mean, for me, it was not very surprising that, you know, that thermo is by far the most used mass specs in Australia, but it was, yeah, I mean, it's certainly, when I hand over to Pepe now to showcase the web application, you will see that despite people use thermo instruments, the results are quite different. Let me put it that way.
Can I ask a question, Ralph? It's Laura here. Is there a breakdown in the distribution of labs across Australia? Like how many are from different states, or like where the labs have come from?
Look, we have this information. I mean, so it can be easily. It's probably a good idea, Laura, just to add this. So we have the information, obviously, where data sets came from and whatnot, and we can disclose.
Even just like the states, like not have to be too detailed. Like, be interesting to know like which states have got the most facilities. I would say, yeah.
Now, this is a good point. Let me write this down, because this is certainly one thing we can easily, you know, find out. That's not yeah. Any more questions? All right, then look, over to Pepe, and yeah, looking forward to your presentation about the or your demonstration of the website that you put in place.
Hello, hi everybody. I'm trying to do the sharing. Give me a second. Tell me you see the web page. I'm just assuming.
Yeah, all good.
Yeah. All right. So to start with, okay. So I'm gonna start saying that this is a bit of a almost complete, but still on the work in progress side. So I'm gonna do the live demo. So something is gonna go wrong. So be patient, and it usually happens that way. Right. So what we did with the data has been already said by Ralph. The one question, a couple of things to notice is that we essentially use FragPipe to do the data analysis of everything. We use the same parameters for every data set. That means that we had to accommodate both high resolution and low resolution of SMS with the same parameters. You know, we just didn't want to change parameters for all the different data sets, at least to start with. And this is a discussion that we can have later if we should. But that means on the web page there will be a bit of information about all the parameters that we used. Some of the parameters for the quantitative analysis were we used a bit more conservative, so we definitely added max LFQ, but we used a minimum of 2 ions, so there would be a few less proteins that will be quantified just because of that specific problem. But for ideally, we put all the information in there so you can look at it in your own time. And as soon as we're done, probably by Lauren, I'm pretty sure that we'll make it by Lauren. We can just release the webpage so that you can actually go and look at the data. So what I want to do right now is mostly, rather than commenting on everything in there, I'm just going to give you a little bit of an overview of how we show the data and what you can do with it. I'm hoping that once we break off that I get a lot of feedback and also what you would like to see next, so that or more or different ways so that we can correct it and add it in there. So to start with, first piece that we're looking for, it's a bit of the quantitative analysis. So you're going to have a space for a part for the proteins and the peptides separate there. I'm hoping that you can see it. Try to make it so that it fits a small screen, but we'll see how that goes. The first piece is about the inferential expression. So here we're showing there will be a bit of a figure detail, so it will explain everything that it's represented in the figure. That for every plot there will be this bit of an explanation in here. But this one essentially is the count of proteins that have been classified as statistically significant. So of course, what we're expecting to see is essentially to have 5 proteins, which were the spiking. So anything on the green is the true positives, everything in the purple is the false positives. I need to make a couple of mentions. So first of all, we're missing one data set still. It's the one data set with waters. We had lots of issues with waters and frag pipe. Yeah, to the point of, we had to write, we tried to write to the to Alexei, but nothing to be done for the moment. So we'll try to solve the problem. And the second part is that the goal is to add also the bioinformatics submissions, and so that everything is shown into the same plot. So far, the bioinformatics submissions are not here yet. So we'll add that information in the next week. So when you'll see, you'll have everything, both the data analysis that we've done across all the data sets, and then the data analysis that each lab has done on their own. We also have a few glaring outliers in here, which we are going to have to check if there what's going on if there is any particular things that it's going that wasn't supposed to happen, just mistakes on our end or some other problem. So we'll have a double check of all of those just to make sure. But you can start seeing that there is in any case a bit of a quite a bit of a variability across the number of false positives. But the vast majority of the data set in any case that do hit the mark and finding all the true positives in there. So the way that we try to show the data here so that you can sort of overlay some of the metadata in here. So for example, you can add which instrument manufacturers it's in here. You can also kind of mass analyzer type. So you can browse at your own leisure, and also you can order it by different aspects of the metadata, or even if needed, if you're really interested into looking at specific things, you can also filter them out so that you can just focus on specific mass analyzer instruments, columns, or anything of the sorts. And all these it will be available across the board in all the different different looks in here. So aside from these, we made a decision at the beginning to just look at proteins that are, statistically significant at, 0.05 adjusted p-value. We added this one just because at the moment, just to see if you prefer to, restrict for protein that is significant, log-fold change greater than 1 or not. It doesn't really change the aspects of how variable these results actually looks like, but it's just a different way to look at the data. Another aspect that we've been looking for is the ratio accuracy to see how well could retrieve the measure of the ratio between the two samples of the 5 spiking proteins. And again, we have a bit of an outlier which we'll need to double check. Then everything is okay. But across the board, you can see the vast majority of all the participants have a pretty good, could actually measure the ratio of the proteins or the spiking proteins very accurately, which is a bit happy, and I don't know if it's surprising to everybody, but just to see. You can look at specific data sets just to see what that the measure log2 ratio with respect to the expected, so that you can actually dig a little deeper, especially for participants like participant number 4, which has a lot of data sets in here, so you can dig a little bit deeper if you want to look at some of the small difference that there might be between small data sets in there. There's also a bit of a look at what the imputation looks like. So again, here is the protein level. So how much of imputed values you have with respect to not imputed, and to see if if there is a lot of variability across the different data sets. Actually, there isn't much of a variability in terms of imputation, although, of course, you can look at all these also at the peptide level, but I'm just going to jump for a second in there at the number of protein that has been identified. There is a lot of variability across the number of proteins that have been identified between all the data sets in here. Now in here, I'm showing number of proteins that have been identified at with different number of values. Now these values are the max LFQ values. So for a protein to have a max LFQ intensity values, sorry, that happened. During FARPI, you need at least 2 peptides that is shared at least 2 of the replicates. So there is it's a bit conservative in terms of, so the number of protein that have been identified with either MSMS only or one value is probably a bit inflated. But again, comparing these across all the different data sets, because they've been treated all the same, you can still see, we can have a little bit of an idea of what the relative terms that looks like. So, even though the level of imputation will change so much, there is quite a different, but variable number of proteins that have been identified. Some of that it's probably due also of, the kind of gradient length that have been used, because you can sort of order it here and see that. Some might be due for shorter gradients, and some might have pretty long gradients. So this might be a good way to even starting to make a bit of a comparison between that type of number of identifications. You can restrict the number of the proteins by the number of values if you want to just to compare a little bit more proteins that are being consistently identified across all the different data sets. Similar, I'm just going to reset everything here. For the quantitative analysis, you can also look at the peptide information. So here, it's similar as to the proteins. We're expecting essentially expecting 10 peptides to be identified and classified as significantly, statistically significant different between the two samples. There is more variability with the peptides. That's sort of expected. So nothing new there. You can also look this is with the IRT spiking solely, but we also try to pull out all the peptides that come from the spiking proteins as well. Again, there's a bit of the outliers are still there, so we'll dig into that. But you know, you can the number of peptides follows very closely the one very closely the number of proteins that have been kind of the variability across the peptides is similar to one that we saw for the protein. So specific for the IRT is you can also look a little bit of at the accuracy of the ratio estimation. Again, there is a lot more variability at the peptide level, but there's definitely some data sets and some combinations, I'm going to call it, of instrument, columns, LC, and so on and so forth that actually hit the mark very well. In order to go a little bit deeper, to give you the opportunity to look at the data sets or more at comparing the data sets and what it looks like, we're putting some QC plots in here so that you can dig a little bit deeper to see, you know, what could possibly be difference between those. So we have in here, there is the for chromatographic peaks. You can see what the retention time length is in difference between the different submissions. Again, you can overlay some of the metadata information if you're interested in to see what the gradient length was, and so you know what that looks like. In here, this is the peak shape factor, so it's essentially tries to measure the shape of the gradient. Sorry, the shape of the peak. So a negative value would be a tailing peak, a positive value would be a fronting peak. But you know, you can peruse the data and compare it across the different data sets in here. So there are other you know, aside from some I'm going to call it some outliers, most are have, you know, very similar peak widths, or you know, although some have very small peak widths in here as well. So we're looking also if there is a difference in you know, sequence length or you know, things like mass errors. So you can see if some have something like this specific data set here that actually looks this one is it's been an outlier across the board, so it's something that we need to check very closely. But most of them all these data sets through FragPipe will go through a recalibration. So all we're showing here is the mass error before calibration and after calibration, but you know, you can start to have a bit of a gauge what is the difference across the board. You can see that, for example, one of the, if we overlay something like manufacturer, you can, not the LC, sorry, that goes. Thermo instruments tend to have, you know, lower spread around the ppm error with respect to other manufacturers, which is, you know, kind of expected as well, but interested to see. We have a page at the end that allows you to look at all the information about the submission. So this is how you know, the Excel spreadsheet is essentially brought it in here, so you can look at all the different. This is non-manipulated, so I didn't touch this one. So anything that has been imputed in there will show up here. So you can, if you're interested to see some information or some specific data set, you can actually go and look at what was imputed and put in originally without us having to do anything in order to show it up onto the app. We are also trying, we'll have a place in here where you can actually link, it's not ready yet, but where you can actually link at each thing, each data set. So for example, you can you know, NMD will have all the different data sets on its own. So you can look at the, you know, quality control of the quality control page, mass dynamics. So there are specific information for the, you know, for the single data set. You can also look, at all the information around the pairwise analysis, and you can start, digging a little bit more deeper into, what the false positives looks like and why some false positives might come up and so on and so forth. So this is all. Hopefully that kind of makes sense and it give you enough to have a little bit of a discussion of what you would like to see or what you like or what you don't, or if there is anything that you would like to add to the page.
Well, thanks so much, Pepe. So look, I mean, this is actually, as I said, this is where we are at the moment. Pepe, I think, has done a fantastic job in compiling all the data. What's going to happen next? And let me just share my screen again. So what's going to happen next is, so as Pepe said, so we will share probably after launch the URL of this website, so every participant gets full access to this. You will also get an email from me after launch, just disclosing your particular participant number. So because we won't have the website, everybody can log on, but you're, for example, participant 6 or whatever, right? So you can then start in an anonymous way comparing your data sets to others. As Pepe said, we will keep adding new features, visualizations to the website, and also try to come up with some really good comparative comparative analysis at the end of the day, in the hope that we can identify really good workflows or maybe combinations of LC manufacture or column types and then mass spec types. So we're still actively in the midst of analyzing that. Before I'm gonna talk a little bit about what's next, do we have any comments, questions so far from anyone? Okay, so look, then what is going to happen now is, and please don't log off now, because normally when you start hearing the word breakout groups, normally people tend to try to find the leave meeting button on Zoom. I can tell you, so we're going to break out into 6 different breakout rooms, but we have a breakout group coordinator for every room. So you don't have to talk unless you want to, and the coordinator makes sure at the end of the breakout session that whatever has been discussed in your rooms will be summarized by these coordinators. So as I said, so we will now break out into 6 different groups, and let me really just give you just a few words about what we wanna get out from you guys right now. So the first breakout room is all about give us your criticism, right? So I mean, I know you haven't had any time playing with the web application, but we just want to get a feeling, now that many of you, had part of this study, one of the multi-center testing initiative, please provide an honest feedback about, what could we have done better, and really ranging from registration to, was the information package accurate, were the instruction clear, just what was the anticipation, and did your expectation match with what has been presented today? The second breakout group is actually, so we termed it money. Of course, it always comes down to that. So I mean, just a little bit words about this. So I guess that the point of this breakout group is just, so let me take a step back. So the actual cost for running the study was roughly $8,000, right? And this is, by the way, this is excluding the time from Mass Dynamics, excluding the time who prepared the samples. This is we're all in-kind contributions. This was just, as you can see here, it's just the stuff we had to order for sample preparation, but predominantly it's around shipping, right? So the shipping of the samples on trial to the participants, this was really the biggest chunk of the expenses. The registrations did not cover. Also ACF, we chipped a little bit in and we were happy to do this. So what we want to get out from breakout room 2 is just if there was a second study, how much would you be willing to pay? Can you think of any alternative ways how we finance the study, or do you think we have to go purely with registration? So this is all about how can we finance any future studies. The third breakout room will be, and this is exactly what Pepe just said. We want really the participants to have a good experience with the data at the end, and then we want all participants to get something out. So which analysis features are missing in the website? which additional analysis would you like to see? But also, are you happy with the website, or do you think, yeah, I don't know, like, should the results sort of like be compiled, presented to you guys in a different way? So we just want to get a little bit of sense of that. What is missing, or what could have been done differently in that regard? Breakout room 4 is about, okay, I think we're sitting really here in a gold mine of data sets. We have 67 data sets acquiring the exact same sample of known compositions. What are we going to do with it? I mean, should we publish it? If yes, where? Who should lead this? Like, would participants be happy to be named co-authors? Are participants, do you think they would be generally happy if we take their data sets and upload through Pride? So we just want to get a little bit about your thoughts on what's next, in particular with regards to publishing. Breakout group 5 is, I think it's a very, look, we called it hooked or fed up. I know you had no time really dabbling into the data, but so far what you've seen, do you think this is useful for you guys, or do you think, look, I'm not going to participate in study 2? So, do you think study 1 was good, and would you participate in any subsequent study, whatever this might be? And if there was a subsequent study, this is breakout group 6. It's like, what should we do for the next study? I mean, in this study, we have tried to drill deep a little bit into DDA and trying to find workflows around data-dependent acquisition. But what's next? What are you interested in? Is it metabolomics, lipidomics, phosphoproteomics? So what should we do next for any subsequent study? And also, who should lead this? I mean, of course, this initiative came out from the Australasian Core Facility group, but it doesn't need to be me or Ben, or like, we just want to get some feedback. Who would be willing to be actively involved in a subsequent study, and then how could we go forward from this? Because the way we see it, at least, is, I think that the first study was in many ways the hardest, in such that like, we had to put all the different things in place, from registration to information package to like mass dynamics, put a lot of time, I can tell you that, a lot of time into this website. But we have the infrastructure now, the framework there for subsequent studies. So who would be willing to have a little bit more engagement in subsequent studies? So this is breakout group 6. So I think we roughly have maybe 10-15 minutes time now for discussions, and afterwards we come back in the main room with the breakout group coordinators, just gonna summarize the findings and what has been discussed in these breakout rooms. Any questions so far? Because otherwise we would like to ask Denise, and I think we haven't acknowledged Denise at all, but thanks, Denise, for helping out and for pressing the button so that people magically appear in their breakout room. So thanks so much for that. But anyway, so before Denise press the button, any questions? Okay, if not, then Denise, just work your magic. All right, we're back. So I think there were quite a bit of issues with the Jamboard. I think people could not paste for some reason. I tried to give everyone access, but it says I couldn't share with most of you for some reason. But look, I mean, I hope that the coordinators took some notes, and I try to rectify the situation for the next breakout room. But maybe do we want to jump into breakout group 1, which was Belinda. So Belinda, do you maybe want to summarize briefly what has been discussed give us your criticism?
Yes, I can indeed. We actually didn't have a lot of criticism, which is very good. I think our group discussed the anticipated outcome of study 1, and the website and the information that was just shown to us was really what we were hoping for and what we anticipated from that study. The website's fantastic, and being able to have a look at all of the data and analyze it across in those different ways has been fantastic. There was a little bit of surprise in the variability in the data sets, which again, once we can analyze across all of the data sets, we'll be able to look into a little bit more. And so then we spoke about that variability perhaps being because we had taken that approach of being such an open study and leaving it so freeform in the methods and the amount of sample that could be loaded and the run times. And so we discussed whether perhaps in study 2 or a future study, we would have set methods that were provided. So say 3 different set methods you could choose, and then option D would be that freeform method, but you would actually have those set methods, then we could really compare between. And as the group said, really then be able to compare apples with apples. That was one of the things now with the data sets is working through and trying to work out the best way to compare our data sets once we know our identification, our data sets with other data sets that are similar in the most ways. And so what are we really comparing against? And then I think the other one there was then if the data is published, well, how would someone outside of proteomics look at that data and what would it actually mean to them, especially because that there is that variability across the results because of the open form of the study. What would they take from that? And would they see that there's a lot of variability between proteomics groups rather than being able to really analyze that data? And so how would we present it if we publish the data as well? And then there were a couple of notes on the data and analytics that could be added into the website as well, which Mass Dynamics has said that they'll have a look into and can have a look at those so that we can especially analyze the in-house bespoke data analysis compared with the Mass Dynamics and others as well, so separate them out.
Awesome, fantastic. All right. Any further comments with regards to that, or any maybe criticism that somebody else wants to share despite not being in breakout room 1?
I had a quick thing, and I don't know whether it can be solved, but the Excel spreadsheet was a little bit painful to fill out, but I'm not sure there's an easier way. So it was fine, but that would just be any thought process around streamlining that metadata collection.
Yeah,
but it's a tough problem.
Yeah, I think you raised a good point. This was actually also just briefly discussed because I was in breakout room 1 as well, that it was a bit of pain to fill in. It's just that, I think it's very difficult to strike a balance between what kind of metadata do you collect, and especially, like if you use a thermal instrument, you might be interested in different parameters than Bruker. So we tried, like I know Tara and Belinda tried sort of like to produce an Excel file that fits all, but I know especially the bioinformatics data set was very, I understand that people didn't fill it in because they felt it might be too cumbersome just to, to fill it in. So I completely take your point, and I think it's a good suggestion, just trying to streamline the Excel files. Yeah, thanks. All right, breakout room 2. So Matt, what about money?
Unmute myself. Sorry, I was just putting a sticky note on my own page. So there wasn't a huge number of people in the room who actually had any control of money, but most people thought that it was a pretty reasonable cost of what they for what they got, for the amount of information that they got and things like that. I mean, it was pointed out that the majority of the costs were actually borne by each of the facilities as well, with regard to, instrument time and solvents and things like that, anything else that they had to contribute. And that's something that we can think about for later on, depending on what we do next, as to is the cost, how much of the cost is actually going to be borne by whoever is preparing and sending out the sample, and how much is being borne by individual facilities if they have to do sample preparation or things like that. It was pointed out that it was relatively cheap because someone had been experienced a similar metabolomic study where they were asked to contribute $6,000 to participate, but they were required to buy columns, NIST extract, a whole lot of other things to be able to participate in that. So people were pretty okay with the amount of money. So I'm going to skip the question about how much you would want to pay. The last question of how would we want to finance it, the immediate one that came up was, I mean, the obvious one that I put forward was you get the companies to do it, but there's a whole lot of ethical reasons to why not to do that. Biocommons or NCRIS was actually mentioned as a source of funding to be able to do this. And then people have also been putting things on, like the APS could fund it. One of the other things that actually came up with regards to money is if we turn around to try and publish this, if we decide to go to an open access journal, how are we going to cover the cost of that? Are we going to go back and ask facilities to cover the cost of open access journals? Although in saying that, some of the open access journals would probably do it for nothing. That's a question for later on when we decide where we're going to go and whether we want to do that. So, yeah.
Well, thanks, Ben. I think it's a good point. I mean, with cost associated with publishing, yeah, I haven't thought about this, but it's certainly, yeah, let's see what I think it's breakout room 4, but let's not jump the gun. Any more comments regarding how financing studies?
Could we ask other groups, say overseas, like in the US or Europe, how they fund their standardized like studies? Like I don't have any idea, but could we get some ideas from them and explore those options?
Yeah, I think that's, now you go.
I was going to say we need to talk to whoever the proteome study group in ABRF is. So people like oh man, his name's just gone out of my head. So there's a couple of guys that I know who do manage those studies. So yes, we could quite easily talk to those because they've been doing it every year for the past 10 or 15 years. So they've got a lot of experience in doing this. Yeah.
I mean, but having said this, as far as I know, it's covered by participants, as far as I know, like these studies. But it's a good point. I mean, APRF is certainly, because APRF, for those who don't know, I think it's in the US, and ESMED as ESMED said, they run annual studies with various different things, and I know Mark has been involved in some of them, and so yeah, we can certainly get some ideas.
The last one I participated in, which was I think 2019 or 2020, it didn't cost me a cent. They just basically, you registered your interest and they sent you the sample. So yeah, I didn't have to pay anything for the last one I participated in.
I mean, I have to say, I mean, I quite like the idea about contacting, NCRIS or maybe BPA. I think this could be something they might be willing to sponsor. Yeah. Okay, cool. Breakout group number 3, Mark. So making most of the data. So what is missing, and is the website being liked? And yeah, just give us a spill about that.
Yeah, sure. So just general consensus and first impressions that they will seem to be pretty happy with the webpage and the types of visuals that were presented. So obviously it's hard to consider a lot of other things that might be missing, but without having time to actually go through the data. So, there's that appreciation. And I think, as people get their hands on it and spend a bit more time, scrolling through the different ways in which you can cut and compare the data, they'll probably find some more things. That being said, obviously the variability on the false positives was flagged as really interesting. And so perhaps looking at other visuals that look a little bit more in detail about the false positive rates and exactly what constitutes those rates and what is it that's accounting for those differences, particularly across the data sets. The other good suggestion that popped up was the ability to alter some of the p-value cutoffs, for instance, or other statistical parameters to see how that alters the overall results. So we have, I think Pepe mentioned or showed that you can do that, for instance, on fold change cutoffs, but perhaps, changing the p-value thresholds and whatnot might be also really interesting to interrogate what effect that has on the results. And then some other visuals that came up were, or a good visual suggestion was to look at the spread of the peptides across a chromatographic time. So, especially if you look at it from a linear gradient point of view, I think that would be quite useful to show. So that was quite cool. And we've just had a few others that have been added while we're talking, which is nice. So one was it will be interesting to contrast proteins that are only found in certain groups. So versus others, for example, having a proteomics ruler to kind of determine if the false positives are only, or whatever's being identified, how they sit from a ranking or abundance point of view. So yeah, that's probably the major things I think that have popped up.
Yeah, I think the last one is a really good idea. And I think we discussed this before, but for me personally, I think it's really interesting also to see like how many of the false positives have been imputed, because imputation is always one of these black box mysteries that might drive the separation. So yeah, but I think all good suggestions. Any further comments from the group?
I had one thing that I thought would be nice if we could somehow get a bit of, I think it's a regression on some of the variables versus the outputs. So the survey data that I saw Erwin present was great with things like parameters in the method. Some of those are quantitative and could be treated as quantitative rather than categorical. That might be quite hard to integrate, but that's just if someone's like feeling super motivated, that might be awesome. Treat some of those as quantitative variables.
Yeah, that's a good point. Yeah. Okay. Great. Well, thanks, Mark. Okay, breakout room 4. So, Johan, are we going to publish or not, and how?
The first comment that was made was, in essence, that you need to draw conclusions first. So, based on the analysis results. Otherwise, it becomes an advertisement that the results are available, not necessarily a publication, which isn't necessarily a bad thing, but it's just something that needs to be kept in mind. The other comments made related to what is meant by a publication. So at minimum, that might be a report that gets produced based on standards that are available. And that's because that might be important for things like NADA accreditation and actually demonstrating to auditors that you're undertaking inter-lab comparisons. Manufacturers might also be interested in that type of output format, so just a simple report, but it might also be white papers, regular update documents that are just published through free platforms, or it might be data notes all the way through to peer-reviewed publications, but then again based on what the actual conclusions are that are being drawn from the results. And it was also noted that those publications, regardless of what format, I think, would actually be important for new proteomic users. So basically to gain context regarding the types of results that are actually being acquired. And the last comment was just based on whether people would be happy to be named as co-authors. The only instance where that might not be the case is if it's possible to cross-reference authors with the metadata and identify facilities. I think that was the only potential drawback. And you'd obviously have to get the permission from all the contributors.
Yeah. Well, thanks, Jan. I mean, especially towards the last point, right? I mean, like this, I think we discussed this right from day one onwards, because I mean, first of all, we would never put something in a public domain without really written consent, first of all, because as you know, right, I mean, like, despite we de-identified the sample, but if you really, I think if you really want to know who is who, you could, open the all the metadata behind the raw files and, get the serial number. And I think, it is possible. So I think it's a very good and important point that you raised, Johan, there, that I think even, de-identified data, I think could be potentially traced unless you really, change like the raw files themselves or change them somehow, which I think we don't have the means to. But I think that's, this is an important point, which I think, we're fully aware.
In some of the other studies where they've published results, they haven't actually even provided raw data. They provided the process results, which you can obviously then improve that layer of protection. So that might be something to consider, depending on obviously if you go for a scientific publication, ideally you'd want, some of the journals would probably want raw data, but if it's a report or something, as Johan suggested, that might mean that we can easily navigate around that.
Yeah, I think it's fair points. Yeah. All right. Any further comments? All right. Nick, what do you think? Breakout group 5, hooked or fed up?
Well, I think the general conclusion was, yes, it was very useful. And would you participate? Yeah, I think everyone in the group agreed that it was useful, or that they do it again. Although we did have a very metabolomic heavy group, which meant that were they particularly interested in IRT peptides? The answer was no, not really, not at all. But they get the idea. And I guess this is a very proteomic heavy part of the session, but I'm sort of conscious that there's a lot of other people doing lipids and other things that in a sense, this study's left out. But they did mention that there's some other metabolite type arrangements going on around the place in other studies. What did the other question that was sort of sitting there was, what did you find useful? That's a little bit hard to answer, given that we haven't had time to sort of scroll through the data. So I know that there will be stuff in there, like I'm fascinated by being able to look at the difference in sort of what columns were used and trapping versus direct loading, that sort of stuff, but that's sort of something need time to be able to filter through the results on. The other thing that just popped into my head was like where he said, would you participate again, and was the study useful? It sort of came from one of the other groups, was going into the future, the whole reproducibility problem. It may be in the future that part of the cost of doing business as a facility may be that you are required, if you want to be able to publish in fancy journals and all the rest of it, that you do participate in these sorts of adventures, for want of a better word, to be able to prove that you are able to get a reproducible result. So we may not have a choice going forwards as to whether we do or we don't. It may be expected that you do, in order to prove that you're not just making stuff up as you go. So I guess I'll leave it there.
No, I think it's a valid point what you just said. Look, thanks, Nick. Any quick comments? Because for the sake of time, maybe we should just move on to the last one and then start the break. Laura, next chapter.
Yes. So essentially, we all agreed that we should have a study 2. Obviously, there was some discussion about who should lead it, and Ben offered some insight about how long it took to really get study 1 going and how much effort and time it took. So I guess that's something that to consider. Would it be something that is led by other facilities across Australia, or how will we really get that funded? That was the other topic from another room. But we thought maybe, as Belinda had mentioned, we should have more standardized methods rather than just opening it up and having everyone choose what the preferred method is. I think it would be more useful and make it certainly easier for the data analysis perspective, because you would hope there'd be less variability, but I think that would be much easier. maybe we could use a more cost-effective sample. Someone suggested urine or something that could be easily obtained. We could even reuse sample one from study 1 if everyone has any left over in the lab. I know most of the people in the room did say they had some left over. Perhaps we could focus on more DIA-MS based acquisition methods in the context of proteomics, so peptide or protein-based mass spec, rather than DDA, because that we know as a field it's shifted certainly in the time that the study has been developed. It would be a more useful way to sort of assess the standardization across different facilities. And do we need to explore looking at more like metabolomics or lipidomics, not just peptides, proteomics? That's something that was also discussed.
Awesome.
So they were the main points.
Awesome, thanks, Laura. I think all good and valid points. Anything to add from the group? Any urgent comments?
I was just wondering, is there a biological sample we could have that would be possible to run metabolomics and proteomics on? Same sample gets distributed, but both
Urine,
spheres
for
can run.
example.
Yeah, urine was one that I could think of.
Yeah, it's a good point. All right, look, I mean, thanks so much, everyone, for, I think, a great session 1. Let's have a 10-minute break now, and then I think we reconvene. Let's say, Ben, what do you think? 2 or 5?
2 in Sydney time.
Yeah. Okay. Awesome. Thanks, everyone. See you in 10 minutes.
Time for our second session of today. It's going to be focusing on the core facility workforce. Who are they exactly? So I'm very pleased to introduce Sech Joy Singer, who is the CEO of the Queensland Cyber Infrastructure Foundation. And you might be thinking, how does that relate to core facilities? workforce, but he comes with an excellent track record in this sort of research facilitation area. He's also a adjunct professor of research infrastructure at UQ. And prior to that, spent many years as director of research infrastructure at UQT. And it was, I think, during that phase of his career that he really sort of got to grips, as it were, with this interesting position that many of us find ourselves in, where on one hand, we're wearing a kind of professional service providing hat, whilst on the other hand, we're still very much wearing our academic hats. That's what got us interested in science and hooked in the whole process in the beginning. So what we're going to do in this session is we're going to have a 20-ish minute presentation, and then we're going to go back into the breakout groups, and we've got a set of topics for us to discuss in smaller groups, and then as before we'll come back and have a general discussion. So without any further ado, over to you, Sach.
Thanks, Ben. Thanks everyone for having me. So let me see if I can share my screen. Hopefully that worked.
Yep, that's good.
It's good, yeah. Hold on. So Ben, I mean, I'm deferring to you guys about how you want to do this. I'm certainly comfortable if people wanted to ask questions throughout the talk, or I can certainly just go through the talk and leave it till the end. I don't mind.
Certainly popping questions into the chat, I always think is the easiest option with the online meetings.
Yep. Certainly I won't be able to pay attention to it, so you might have to prompt me if there's a question. Yeah, so thanks for the introduction. So I think I will certainly talk about kind of my experience with this, and in fact it is something that I'm quite passionate about and have been dealing with for a number of years. Like you guys, many years ago, I ran my own core facility, not in proteomics, it was in cytometry. So my last two gigs, one was in the US and the other one was at Imperial College in London. But so I do understand the trials and tribulations of trying to run core facilities. I start off with just this slide here. It's a bit long-winded, but essentially I'm just highlighting part of the response that myself and my colleagues in the Queensland Major Research Infrastructure Alliance made to the NCRIS roadmap exposure draft. We certainly felt that the Commonwealth, when they put that kind of document together, it kind of oversimplified by capturing all of the research infrastructure or core facility workforce under this very broad term of technical, I think technicians or something along those lines. But in reality, the core facility workforce is a lot more complicated than just technicians, if you like. And I think they failed to acknowledge that the tensions that do exist in the system that really pulls and pushes between kind of professional service delivery and still having to have academic vigor and being peer reviewed and so on. So what I have found over the years is there's actually quite a number of different profiles in core facilities. And the next slide, while it's a simple slide, we're probably going to spend quite a bit of time on this slide here. So from my experience, the reality is the core facility workforce is very complicated. It's quite complex. In some ways, the titles don't matter, but let me see if I can go through some of the different kind of profiles of core facilities. The first one I call technicians, and whilst that term has been used very broadly, and in fact, the term technicians is often used to describe people who set up teaching and laboratory labs, for example. But also sometimes they use that same title to describe really highly specialized technologist who runs very complicated instrumentation. But I would suggest that it is an important part of the workforce, but technicians, in my mind, and certainly, this is not a hard and fast rule, but I often characterize technicians as those people being generalist. They're usually on the professional scale, but they're generalist and they tend to look after, let's say, a suite of things, but maybe not go deep into a particular technology platform like proteomics, mass spec, or any other kind of heavy technology underpinning. And this is where a lot of universities, especially universities, fall into the trap in that they try to treat everybody the same. And that opens up a huge can of worms. Research infrastructure specialists, co-scientists, technologies is what I would describe, which probably describes many of you. You often are really, really specialized in your technology platform. Often you don't have your own independent research, but you're kind of trapped in that. In some universities will put you on the professional scale, and some of them will put you still on an academic scale. It kind of depends on the university. The key thing about the specialists is that you're all about the technology and the application of the technology to a breadth of research questions and problems. And the distinction that I draw between kind of the core scientists and what I call academic contributors is the core scientists may not necessarily have a school home, like an academic school home or a discipline home, but the academic contributors do. And this is where the interesting tension happens, because if you're an academic contributor, it's just a very loose term. So you might be called director of proteomics facility, but when it comes to promotions time, it's show me your KPIs that are like an academic. And I think that is where that tension arises, because your workforce model or your work allocation model, and many of you are probably familiar with work allocation models around teaching and learning contributions, research contributions, and service and leadership. Universities don't spend a whole lot of time nuancing that for you because you work in a core facility. You still go to the faculty-based or school-based promotions committee and get shut down often because you don't meet the traditional metrics. And academic contributors are usually, it's meant to be a part-time role often, the core side of things, but you end up having to do everything and maybe not succeeding in anything because your bandwidth is pushed. And they're the group that I'm most concerned about in this ecosystem. Of course, the research environment's changing rapidly. When I was at QUT, I had about 150 people in core facilities, and many of them were non-PhD engineers with lots of industry experience, software developers and programmers who didn't care about a PhD. They were very good coders. But that's what I needed for the research projects. I didn't need somebody PhD qualified. I needed somebody to do the coding. So the actual workforce profile is a lot more complex and different than what people actually think it is. And in some instances, I really appreciated the depth, somebody who's gone through the PhD and really knew how to apply a technology to a particular domain of research. At the same time, I appreciated somebody who came, maybe not a PhD, but had heaps of industry experience with lots of different applications of a technology. So I had to really cater for both. And also what has changed over the years also is there's new types of cores emerging, core facilities. Like I had a core facility in biomanufacturing, which was really about a combination of synthetic biology and sort of fermentation and so on. And in that context, we were working at sort of technology readiness levels of 6 and 7. I didn't need somebody PhD qualified. I needed somebody who understood how to run a semi-industrial scale biofermentation rig. I needed a mechanical engineer, and I needed somebody with electrical engineering know-how. And when I went to HR and I said, yeah, I want to appoint somebody with this 20 years of industry experience, they said, well, the highest you can go is a Hugh 10. I'm not going to hire a Hugh 10 engineer who's worked for 20 years. So this is where the system really does fail in terms of the workforce. I think the very first starting point is to acknowledge that there's a diversity here. It's not just one profile of people who work in core facilities. I know with this audience, you guys are very much coming from a like a proteomics, mass spec background, but as a collective, the breadth is even more, much greater across the research infrastructure domain. on that note, was there any questions for you guys on that part of it? That's quite a bit in there.
So nothing in the chat yet.
No, okay, I'll keep going. Everybody's favorite topic, professional and academic, right? You know, the biggest mistake universities make is they make the system dictate the strategy and planning. So HR dictates, you know, what you can and can't do. And they often refer to the enterprise bargaining agreements as a, you know, we can't do anything. 99% of the time, it's not true. You can work with the EB. It's just really about local level systems and processes and policies. You got to remember the professional track was designed, I think, by the British, I don't know, 40 years ago or something. It's so antiquated and irrelevant today, but it still exists because in order to change that would take so much effort. And in some ways, I would argue that's not in the best interest because people are worried about other downstream ramifications. And the key difference really is that, I don't know if you guys have understood this, but the professional track is about the job. It's not about the person, it's about the job. The academic track is about the person. So already within that system, you're creating a divide, a dichotomy there, where at one level you acknowledge the individual and the other one is just about a job, with the presumption that because it's just about the job, you should be able to just replace somebody. But as you all know in this room, how difficult is it to get somebody with the right expertise and recruit them and retain them? And if you can't promote them and give them a career pathway, what chance do you have for recruitment and retention? And this is what that really annoys me about the system, is because the HR people will say, well, as a leader, you should focus on recruitment, retention, and developing your staff. But then they hamstrung you by saying, it's about the job. You know, write the PD to make it a Hugh 9, write the PD to make it a Hugh 7, whatever. So I think there are systemic challenges in our higher education system in Australia, and to be honest, in many other parts of the world, that is quite problematic. I think, you know, I'm always disappointed when many of the universities, quite a few universities will say, oh, we need to make it efficient. So let's move all the core staff into professional track. Or, you know, and I think some universities have done that in the past. I think it's a huge mistake. So what you have to really do is work out a way for the HR tool. And in fact, the EB is a tool with two tracks, two human resource tracks. And if you treat them as such, as tool, you got to work out HR to help you to use that tool. And so this is a flipping of the conversation from thou shalt do it this way to help me to leverage this tool so I can hire the best people and retain the best people. The small win I had at QUT was, one of the small wins I had at QUT, for example, is I convinced HR to advertise roles either as professional or academic, depending on what the candidate wanted. You know, so I was able to go to market and say Hugh 10 or academic level B, depending on candidate. You know, so you can do it. You just have to, you know, work hard at convincing the executive to be able to leverage that flexibility. But I always go with the argument, aren't you interested in us for the organization's benefit, recruiting the best and developing the best and retaining the best? And if you're in my way to doing that, are you really helping the organization? Any questions if I move on? No? So there's been, I think Ben alluded to the fact that several people have asked about this sort of specialist part. So I guess Ben alluded to the fact that my QUT experience, so this is where I took on some of the learnings of the academic specialist at Melbourne University. And then at QUT, I took it kind of to another level where essentially what I said was, I want to put anybody who demonstrates particular attributes, onto the academic track, whether they're PhD qualified or not, purely as a tool so I can promote them based on bespoke KPIs and metrics. And the most important change in the university was the academic career framework, so which is the framework that decides the metrics for promotions, so teaching and learning, research and service and leadership. There was a dot point in there about research infrastructure in every all three columns. So for example, under teaching and learning, you didn't have to say, I supervise 2 PhD students and master's students. You could say, this year, I trained 200 HDRs on mass spec methodology. I ran X number of workshops. Under research, well, you guys are all familiar with it, the recognition of actual collaboration and middle authorships and so on, and method development and so on. And in service and leadership, well, hell, you guys are all leading a technology area. Make that very explicit, that is a key component of an academic activity worthy of being recognized as leaders and for promotion. So I think that was probably the biggest, most critical change in that QUT system, which, as far as I'm aware, no other university, academic specialist at Melbourne Uni and QUT, as far as I'm aware, no other universities adopted that, as far as I'm aware. And I think it is important to acknowledge that, jobs are static whilst careers are dynamic. They can change and move. So I have had instances where some people will become specialists, but then say, I want to do some independent research with this particular school. And then we've been able to accommodate that. The good thing about that flexibility also is retention, because as you guys all know, sometimes if you pursue the independent research programs and you don't get a grant, you don't want to necessarily lose those people, because the ARC and the NHMRC is a bit of a lottery, as we know as well. So what we do often is at QUT, we move people from specialists to academic contributors depending on what the circumstances are as well. So there was flexibility built into the system that, again, helped with retention of core capabilities for the organization. And for me, it's also something, a very simple concept of just being equitable, because you got to remember, not all research infrastructure staff have aspirations to do things that gives them international profile. They're quite happy to come in and do a great job and go home. So this is not about everybody becoming specialists. This is about giving people the opportunity. So there's an option available to them if they chose to pursue that advancement, and they're willing to work towards those metrics in order to be promoted. And I can tell you, not many people actually take up that option, because some people are quite content coming day to day, doing great service and going home with a paycheck. And that's fine as well. So I think, people sometimes misinterpret the specialist path as something that everybody has to pursue, right? So in some ways, it's a little bit different to traditional academic promotions where, sometimes people just get promoted because of time and what they've done and how much time they've spent. So it is a little bit different. But I think the real other important thing is the fit for purpose key performance indicators can be a little tricky, because that might look a bit different to somebody running proteomics or genomics facility versus somebody who's doing, fabrication and, at ANFF, for example. So it needs to be nuanced. So it does take a bit of time and effort. And this is the most difficult part about this challenge, is that, you are butting heads against kind of the traditional academic culture. That is why not many universities adopt, or take the time to change the system, because the traditional academic culture does struggle a little bit with kind of the halo effect, because if they don't look like me, then they can't possibly do this job. So I think you got to you do really need a champion to help to drive some of the change, which is, it's quite a bit of a bump that you have to get over and convince. And you are also dealing with, peer review, reward and recognition system in academia. It's really about me, myself, and I, which is somewhat counter to research infrastructure and core facility, which is about enabling lots of people. Right? So I think you do have to kind of acknowledge that is the system, the peer review system, even though we talk about collaboration, and I've been part of many centers of excellence, and I can tell you, there's still quite a bit of self-interest when you put a center of excellence together, right? So you do need a champion, an executive leader and champion that will drive this change. Sometimes, and without naming names, I've seen lots of passionate pro-vice chancellors of research infrastructure who have butted heads against the system and haven't been able to make change. So it's not an easy task. Just a quick plug for course 2023, if you're interested, and if you're aware of it. Otherwise, I'm happy to take some initial questions.
Excellent. Thank you very much for that. So yeah, if anyone wants to jump in with a question, feel free.
Sash, that was really phenomenal. It's just actually something I was chatting with Kirsty just last week. Just wondering, I mean, it's really amazing to see the changes that you've managed to get made at QUT, but how do you actually get the academics to actually kind of go along with those changes and change their mindset?
Look, I was lucky in that so Margaret Shield, the Vice Chancellor, is a mass spec person.
Yeah.
Ian McKinnon, Bronwyn Harch, all those people who are in executive leadership positions were willing to hear what I had to say. So it is, there is a bit of serendipity there in the case that I had the right people to make the change. Now, in terms of the broader academic community embracing it,
yeah,
I think in some ways it was really about, your personal effectiveness in engaging. So, there's two laureate professors at QUT, Dimitri Goldberg and Christopher Varnakolik, and both of them, I had, there are often times where, I myself had to put to go to them and say, this is not taking away control from you. This is really about enhancing your programs by having these specialists embedded as part of your research activity. And it was a little bit different to, for example, Dimitri just came from Japan, which is a different model altogether. It's very much everybody has their own kit and their control. So there's quite a bit of legwork you have to do to bring these important opinion. You wouldn't be surprised. Laureate professors have a lot of influence within an organization. So if you convince these people and target them and convince them, then there's kind of a distilling and trickling down effect that says, oh, this is actually a great model and it can work for all of us. But QUT is also a quarter of the size of a Melbourne Uni or UQ. So there is that element as well. And it also depends on the operating models adopted within the organization. At QUT, it was very much a centralized model, so you can make the change quickly, and everybody's in the one unit. It'll be much tougher at UQ or Melbourne Uni, for example, where a lot of the infrastructure is devolved and it's run by a faculty or
Yeah.
So yeah, look, it's not without many challenges. And I guess to your point, David, about how do you make systemic change across the sector, I have been contemplating this idea of setting up an academy for research infrastructure people. And the idea being that maybe we can make change with NCRA's support as a collective. So there's a fear of missing out. I've been in the universities for a long time. Trust me, when one makes a change and few make a change, the others follow because they fear missing out.
Excellent. Well, I think what would be great if we do our magic with the breakout rooms, and we're all going to break into 6 groups again. We've got the same coordinators as last time, and hopefully those of you who have the Google accounts can access the Jamboards to put down your ideas, and if not, relay them to someone else within your group who can add the ideas. And there's a topic header at the top of each page. So I'm going to pass over to Denise to hit the magic button and Okay, well, welcome back, everyone. Hopefully you've been having as fruitful discussions as we had in our group. It's certainly an interesting topic, and it's, you know, everyone's got an opinion, as it were, and some experience that they were sharing in our group. So now we're just going to go around each group one by one. Now let me see who's the... So our first coordinator is Laura.
Sure. So
I
won't break out group 6. Like we can go back.
Yes. No, I was on the wrong page. My
Okay.
fault. Belinda.
That's okay, thank you. So we had quite a good discussion, quite a good vent session as well. This is a very good topic for us to have. So we had the question, what is the definition of professional staff? And we did speak about that, and then we sort of broadened out in our discussion as well. But largely we spoke about professional staff really being seen and defined as those that don't follow the academic workload model, and largely that point around not doing a lot of the teaching side of things is how professional staff are often seen. Again, obviously, then we talked about the points that were raised in the presentation as well around, well, what is seen as teaching, and then we get to that grey area of training and technical teaching, then being put in the area of teaching, and how is it actually defined. We also spoke about, again, as was discussed in the presentation, around the professional roles being a job or seen as a job rather than a career, and that obviously isn't how it should be, and that real difficulty in career progression, and that's both academic and professional staff as well, but we spoke a lot about that, and the loss of staff sort of over the last year. A couple of us had lost a number of staff, and in those exit interviews, really a lot of the reason for that is that lack of a clear progression for their career. Is how do we get that promotion when, especially for professional staff, there's a set level, and that's the level of the role, and unless someone leaves in a higher position, the roles don't increase in their levels. There is no progression in those role levels.
Yeah.
And then one of Michael in our group also spoke about that academic specialist hybrid, and the challenge in that role being that you get put in either box, unfortunately, and often the box that you get put in isn't an advantageous one for that situation. So even though you are meant to be that hybrid role, you are still boxed as either professional or academic, and often it sort of goes against the way that it should be to be advantageous for you at that time. So again, we then discussed, well, where that it would be good to have that middle ground, that teaching professional or teaching academic type role. But again, where does that sit, and how do you make that role able to meet the needs of the person, and again, able to have that career progression as well. So I think that was the sort of main parts of our discussion, and really
excellent.
A lot about, yeah,
and essentially all roads seem to lead back to the progression and promotion side of things. That's only where our conversations spend quite a bit of time. But let's move over to group number 2, and Matt, you were discussing, should there be limits on what professional staff can do?
Yeah, so I ended up in a room that was just professional staff. I was the only academic person in there, and ironically, I spent more than 10 years as professional staff before I moved over into academia. So I completely appreciated where these people were coming from. I mean, really, on the whole, it became a bit of a, it depends. You know, we did talk about the fact that it does become an individual thing. Like, individuals should be able to decide whether or not they want to do the particular job that they're doing and just do that for ad infinitum if they really want to, and management should be able to manage that situation. But others, they wanted to be able to be recognized for the things that they were doing, and what they see as limits is not necessarily being told your job is this. It's more of a case of all of the things that academics tend to impose on professional staff where, for instance, you have academics who have very little to no experience in proteomics. So they're turning up and they're relying on the professional staff to train them, help design their project, help analyze their data, help them write the things up and things like that. And they don't often get any credit for that, but they're not then able to refuse to do that, because if they refuse, well, then the student's not going to get anywhere. So there is a problem here. So I guess the answer to the question broadly from the professional staff is no, there shouldn't be a limit, but it should be situation dependent.
Cool. Excellent. Nice summary. Alrighty, let's move on to group number 3. And Mark, who was discussing, are academics who run core facilities at a disadvantage relative to their peers?
Thanks, Ben. Yeah, look, I don't think anyone disagreed with that statement. So that was the first thing that off the bat. Essentially, people, a lot of the discussions that we had were really highlighting the fact that, always ended up around a career progression pathway and discussion, and the fact that, academic only specialists, who don't have to worry about running a core facility can focus make decisions that will, put them in a greater advantage from a career progression point of view. And obviously focusing solely on running a core facility means that you can't obviously focus on your own career progression at all times. And so that's pretty much the major theme that came across. And even in instances where some people, some institutions have defined, a specialist criteria, so academic specialist, even though that's a step in the right direction, it still means that, you can be pigeonholed one way or the other, which can still affect how you progress in your career. And I guess the only other point that came up, which is, I think, really, really valid, is that these disadvantages and challenges that are faced by academics who run core facilities are actually directly translatable to professional staff as well. So I'd say you'd probably alter this question slightly and just say any specialist, professional or otherwise, running core facilities at a disadvantage to their peers, because it does seem to be the case. So that's probably the major points from our chat.
Excellent, thank you for those. And let's move on, linking nicely into that specialist debate, for Johan to report on, are specialists the solution?
So based on the chat that we had, it is a solution, not the solution. It's also observed that, not surprisingly, output from a core is directly related to the number of FTEs you actually have available, right? And in that context, when you have specialist positions, you allow for greater career progression, which is the advantage of an intermediate role. Some of the reasons for that are that with specialist positions, you can make a case for recognition of achievements or KPIs that don't fit into that classical academic model, right? So it's not all about publications and winning grant funding. It's about actually making achievements within your specialty. And also because metrics can be really hard to quantify, right? So you can't always assign dollar value to something, just as an example. But as a specialist, you can make a much more flexible case for the role that you occupy. This is all in the context of a need for cultural change, right? So you might not need another title or role, but there needs to be value assigned to a diversity of roles within core facilities. Having a specialist role, like Mark just said, it's a step in the right direction, but maybe it's not the be all and end all, right? It needs to be a bit of both. And we also had a couple of questions. So given a bigger focus on engagements with industry, for example, how do the different roles, academics versus specialists versus professional staff, how do they actually relate to that? And the question of retention and recruitment. If you can't promise career progression, you won't be able to effectively do that. So how do you do that in the absence of having those specialist positions.
Excellent. Thanks very much for that. All very interesting one. So in the interest of time, we'll move on to Nick. How did the discussions go in group 5?
So the question was, is running a core facility bad for your career if you are an academic? So the first question that sort of popped into my head is, are we saying that core management is not academic? Which, yeah, some people would say, no, you're just a manager doing budgets and writing emails, which I know something about. Is core facility, is it good or bad for your career, academic career? Typically, I would say, or I guess we talked about the fact that a lot of the time, you're completely reliant on whatever work comes in the door. So if someone comes in with a project, you're supposed to make it happen. You don't generally have your own research area, which means that what typically happens is that you usually end up with middle authorship on all of your publications, which if you then go to an ARC grant panel or something, they smash you for because you don't have any of your own research area. So that makes being an academic very difficult if you can't get any grant funding. One person suggests that if you want to be successful as an academic, you need to do both your own research sort of on the side as well as running the facility. So I guess if you ran the mass spec facility, you would also have your own little dabbling in doing, I don't know, designing the next greatest gene sequencing machine or something as part of your lab activity or whatever it is that your particular thing would be. So that way you're sort of trying to chart an academic career at the same time as you do the project. There's another post-it note that's popped up here that says, is it bad if you don't have your own research area and senior author publications? Is it bad if you don't have your own research area and don't have senior author publications? As far as the ARC is concerned, when you get reviewed, the answer is yep, pretty much. Or at least that's been my observation. What else have I got here? A core facility could be good, you know, for someone who's wanting an academic career. If you spent, you know, a year or two with the facility and you learned how they work and learned the technology and stuff, and then you went sideways into your academic career with all the expertise that you've gained in a platform, that's certainly the case. But if you're running the platform day to day, I guess there's also that difference between are you the academic who's notionally the head of the platform, but someone does all the running, in which case you've got your own career, or are you the manager that's doing all the day-to-day work of running the facility full-time, trying to make sure everything works? Because there's that sort of difference there between what running the facility means. I'll probably leave it there.
Excellent. I think that covered a lot of ground. Right. So Laura, if I come back to you again.
Yes, sure. Okay. So our question was whether there is a divide between academic versus professional staff. The consensus was largely there is. We then dug deeper into how deep that divide is. That's sort of been addressed largely in other groups, but we talked about issues around supervising students, that sometimes that professional staff are often dismissed in those roles. Issues around getting funding for contracts that often require academics to be a part of that rather than professional staff. That there's often lack of funding for professional development, you know, professional staff versus academics, and recognition for publications, especially, so we're talking about middle authorships here and how that can be detrimental to someone that's considered an academic if they're only getting middle authorships compared to for career progression. Staff retention in the professional stream, if they are seen not to have that level of career progression, that can be difficult. So yeah, I think that sort of summarizes largely what we discussed.
Excellent. Thank you for that. Okay, well, in the interest of time, we're going to take a break, but the Jamboards will remain open. So if you have other ideas or want to chip in on a particular topic that you've not contributed to so far, feel free to keep adding post-it notes or kind of, unfortunately, there doesn't seem to be a way to vote up ones you particularly like, but maybe you can just edit them and just do a ×2 if you particularly agree with a comment. And then probably after Lawn, we'll circulate copies of the Jamboards to everyone, so you've got a record of the discussions that are going on. But for now, we'll do another one of those 10-minute stretch of the legs, and we'll convene at 5 past the hour for everyone apart from the South Australians. And we'll see you shortly.
Okay, so I think yes, it's already 5. I think let's go on. Ben, over to you.
Excellent, thank you, Ralph. So this lucky last session is all about the annual survey, which the great many of the groups have done. So let me just get this sorted out. And hopefully you're seeing the slides now.
Yeah, all good.
So yeah, I just want to kick off with talking about I'll get the acknowledgements done first. So where's get my pointer going? And so this option, I just want to acknowledge Ralph's help in getting the core facilities meetings up and running all those years ago. And the survey is really a spin out of one of those first meetings, and is originally designed with a lot of help from Paula and Mark, who are now both at Mass Dynamics. And it's been refined over a number of meetings since, as well as during each survey, we obviously get feedback and find glitches and things that aren't covered. And so it's been gradually evolving, but there's a core set of questions that have been asked every year now. And I want to give an extra special thanks to the 33 facilities that last July and August went through the pretty arduous task of completing the survey. So obviously without that input, we'd have nothing to talk about today. And if you have any inquiries, feel free to drop me an email at that address at any time. So as I say, it's in the 4th year that it's been going. It opened or ran during July and a little bit into August last year, but the majority of the questions are addressing the calendar year of 2021. The rest of the questions are a kind of snapshot in time of July, and this occasionally gives us a few glitches if situations have changed between that 2 periods. So people might report a salary spend in 2021, and then their number of staff has altered by the time they're doing the survey in July 2022. And therefore, it's occasionally makes it a little bit hard for us to kind of cross-reference different questions. But aside from that, it seems to be the easiest way of doing it. So this time around, we invited 42 facilities from across Australia and New Zealand, and we got 33 responses, which covered 7 states and territories within Australia and both North and South Islands of New Zealand. So hopefully a pretty representative snapshot of core facilities in Australia and New Zealand, and a reasonably representative picture of what's going on in a typical mass spectrometry core facility. So the survey covers 8 different sections. We ask a few kind of basic questions about who people are. We ask them about what sort of equipment and resources they have available, the services they offer, the pricing models, who their customers are, what tools do they use in communications and marketing, where their funding comes from, what their revenue aspirations and planning are all about. And then there's a few future-looking questions where we try and predict where the field is going next. So we don't have time to cover all of this today. So I've got to pick a few vignettes and highlights from the last survey. And as I'm sure you're all waiting for so everyone who commits the survey or completes the survey gets a personalized report where they can see where their facility sits compared to the others. And I must admit, I think I'm going to have to tender Mass Dynamics to do a report for me, because that interactive website looks very superb. But I have a fairly pedestrian PDF, which I'll get to people as soon as I can. So the survey is conducted in REDCap. And as I say, it was open in August last year. So let's move on to some of the early results. So let's have a quick look at who was responding. So the vast majority of core facilities, unsurprisingly, are based in universities, with research institutes as being the second most common hosting institute. But we've got one institute based within a government organization. So people quite often ask me when I'm in this ACF role, what's a core facility? Or, oh, no, we're not a core facility. We can't possibly do the survey. Whereas we generally take the very broad definition that if you're providing mass spectrometry services for someone other than your own research group, you're a core facility, is the way we look at it. Interestingly, we do ask people what they think. And again, the majority of people do bracket themselves in that core facility umbrella, with a few who come into these research groups where, because they're the experts at their institution, they do an awful lot of collaborative work in a core facility style. And then there's a few who don't fit within those brackets, where they may be industry partners or, as I say, government organizations, and so they don't fit quite within that classic definition. The people who are responding to the survey, again, the majority of the managers. We do get a few directors, which, as Nick was pointing out in that previous session, there's a little bit of a difference between, the directors just sitting there taking the glory whilst the managers are doing the legwork. And there's a bit of a split between academic staff and technical staff. So not quite a who you are question, but an interesting one that we ask, and this is the fun of having year-on-year data, is we always ask people, do they have accreditation? And are you planning to get accreditation during that year of the survey? And interesting, this graph looks the same every single year, where the majority of people don't have accreditation. There's always about 10% who are aiming to get accreditation that year. And the number who have accreditation seems to be stuck fast at this relatively small percentage of facilities that are actually accredited. And the interesting part, I can't quite work here, and I haven't teased out the bit from year to year as to whether once people get accreditation, they don't have time to do ACF surveys anymore, or is it more likely that a lot of people who are aspiring to get accreditation don't quite get over the line, and so it gets kicked over into the next year, and that this year will be the one where they complete all the requirements to get accreditation. So that's definitely one of the interesting parts of having year-on-year data.
Hey, Ben, sorry to interrupt. Just quickly, in terms of that accreditation, do you ask what type of accreditation, or is it just
we don't. It's any NATA or similar. But it'd be an interesting one. It's always a horrible temptation where you just keep thinking, oh, I'll add an extra question. I'll add an extra question.
No. You get like 1,000 questions. Yeah. No.
And the survey only gets, so we have a strict 1 in, 1 out policy now, where any new question, you've got to boot some old question out of it just to make it a manageable exercise to complete. Right. So, there we go. So one of the core parts of it is we look at the staffing in facilities. And so this, as I say, this is one of those questions where it's looking over that calendar year of 2021, which now feels like a long time ago. And we ask people what their salary spend is. And we ask them how many FTE they have. And aside from obviously that risk of time shift between the two parts, where the salaries for 2021 and the FTEs in 2022, the average salary per person or per FTE full-time equivalent is just over 100,000 or just under $100,000 per person, which I think most people would agree with, although there is quite a spread. And that, as I say, sometimes I think these very low values and the very high values are a mismatch between the reported amount of salary and the number of FTE. It's also interesting how much of a spread you get in number of FTE per mass spectrometer within a facility. So some lucky facilities have 4 staff per mass spectrometer, whereas other facilities are right down the bottom end of the scale with a very fractional appointment per mass spectrometer, with the average being generally just under 1 FTE per mass spec within the facility. And so you can also see here how the total number of FTEs per core ranges enormously from 24 in some facilities right down to 0.2 of a person in some facilities, with the average again being around about 0.7, sorry, not 0.7, 7 FTE per facility is the national average for this survey. We ask about the gender of users, of staff members, and as you can see, there's quite a wide range from all female to all male, but you also have to bear in mind that about a third of facilities only have 2 members of staff equivalent, so it's not hard to get a skews like that. With again the average overall, if we look at all the staff employed in a core facility, it's 1.1 males per female, so slightly more, bit of a male skew, but not by very much. So we have generally quite a good gender balance within the area. And then we also look at whether people are academic, admin staff, or professional staff. And the pink is the academics, and there's a slight skew overall in favor of academics. And interesting, relatively few facilities actually have dedicated admin staff. And then the residual, just under half of the professional staff. Here's the magic numbers I was looking for. Right, so instruments. And again, just like the staff, there's a huge array of some facilities have over 20 mass spectrometers, whereas others just 1 mass spectrometer, with the average number being around 7.1 per facility. And in orange here, we also ask people how many new instruments were installed that year. And so you can see about just over a third of facilities managed to install something new in 2021. And one lucky facility got 4 new toys in that year, whereas the majority of facilities aren't adding any new instruments. If we break down the different types of instruments within each facility, we can see that as soon as people get above 1 or 2, they diversify the array of instruments. And with the rare exception where you might get up to 8 of one particular type, most facilities, when they get more mass spectrometers, they keep adding different types rather than having, a particular instrument they really love, and they just need to increase capacity within that space. So yeah, there's a general trend there of trying to diversify their portfolio as they progress. So if we look at the instrument type overall across all facilities, QTOFs are the most popular platform in terms of what's currently installed, with Orbitraps, if you lump them together, would actually be the lion's share, but 21% are the quadrupole Orbitrap, with 22% are the tribrid. Sorry, I'm reading this wrong. The triple quads, and then down in the 10% here, this is the other Orbitraps, the tribrid Orbitraps. So you'd have 33% overall. So if you lumped all of the Orbis together, then they would be the most popular one. And so it's interesting during session 1 as to how, in terms of the proteomics data sets being submitted, there was that really strong skew towards the Orbitrap platform for proteomics. We also asked people about ion mobility. And again, it was interesting how there was a very high level of ion mobility utilization in the benchmarking exercise, whereas it's only a relatively small number of instruments that have ion mobility fitted. And again, these are predominantly QTOF platforms. There's 20 QTOFs with ion mobility, whereas there's only 5 Orbitraps with ion mobility, and then 4 of the tribrids, a very small slice of the pie on other instrument platforms. So staying with the instrument area, we dig down a little bit on what was new and installed in 2021. And the single most popular platform with 5 installations were the triple quad or QTrap platform, followed by QTOFs, and then Tribrid's, Orbitraps, and there was a brace 3 single quads got installed. So an interesting array of different types of platforms going in there. And one question here is how much of this is driven by the available budget? Are people putting in more of the cheaper instruments because that's what they can afford? Or are these the most where the demand is for new instrumentation? And the funding for these instruments generally comes from the host institution. So these upper areas, you got several facilities where it's completely funded by the host institution, and then several facilities where it was largely funded by the host institution, with a few facilities managing to fund it from user fees, but also federal grants were a very common one, along with charity and philanthropy funding. So there's quite a spread, but predominantly host institute funded. So as I say, we had 18 installations in total across 12 different institutions, and out of those 18, 9 for every one, so 16 of them were purchases, and 2 of them were seed instruments. No one in this round of the survey was leasing or renting instruments, and no one was purchasing a second-hand instrument. And obviously, it's not just new instruments coming in. We queried people about instruments they were decommissioning, and so decommissioning is running at a slower rate, with only 8 decommissions during that time period. And as you can see, it's the sort of the older platforms, so things like Ultraflex Extremes, the 4800s, some GC instruments here. So yeah, the older workhorses being finally retired. All right, so a key issue for us all is maintenance and how to keep our portfolio of instruments running. And so again, we ask a number of facilities as to how many, what their total budgetary spend was. And not all facilities have that number to hand or want to share it. So we only had 23 facilities responding to that question. And it ranges from nearly $500,000 per year down to a few facilities were reporting tens of thousands of dollars. And obviously this reflects that broad spread in facility sizes. So we adjust that and look at dollars on maintenance per mass spec in 2021. And it sort of tightens up a little bit, with the average facility spending around $20,000 per instrument, with the outliers or the upper end of the scale paying up to $50,000 in maintenance per year. And how is this money being spent? So we had everyone replied to this question as to what proportion of their instruments were on manufacturer's warranty, which is the dark orange. So obviously everyone tries to bundle as much of that in when they purchase the instrument. How much of it is on a full prepaid maintenance contract? And it's interesting how this varies from some facilities where they have everything on prepaid maintenance, whereas other facilities have nothing, and they do the either no prepaid or a pay-as-you-go style system. And then obviously quite a few facilities have a mix where they've got some presumably new instruments still under warranty, some are on contract, and some are pay-as-you-go, as you would expect. So software is an interesting area, and I've certainly been involved in conversations with Biocommons, and there is an enormous number of packages that people use. We have over 40 different packages being reported during the survey. And so here I've just tried to home in on the The top packages broadly for metabolomics, where we can see things like Skyline, Freestyle, Qual Browser are extremely popular, but there's a very long list where different facilities are using different packages. Quite often this is driven by each vendor obviously has their own software, as well as you've got these generalist packages which can take data from anyone with ease. If we flip over to the proteomics side, Max Quant is unsurprisingly top of the pile in that area and extremely popular. And sometimes it's a bit hard. Things like Mass Hunter, are people using that for proteomics, or are they using it for metabolomics applications? And we don't dig down to that level. And then you get things like Proteome Discoverer, which is the third, certainly the most popular of the commercial packages. And often things like Proteome Discoverer might work in tandem with Mascot in that you can send data that way. DIA-NN is shooting up the ranks from a kind of unheard of package when we started the survey, and is now in the top 5 quite clearly there. But again, like the metabolomic space, there's a very long list of packages, and it's always an interesting debate about, is one better or is it just what you're familiar with, and how much of an impact this has on the data output. So again, if that can be mined out of the testing initiative, it'll be fascinating to see whether we should all actually be doing much more benchmarking and using the best tool for the job. So moving on to the user model, we can see here where the majority of people go for either a fee-for-service or a self-service option, with very few facilities in this survey, only 3 that had a significant subscription model utilized in their situation. And within so the orange here is fee-for-service per sample basis, or the lighter orange is the fee-for-service per hour of instrument time, which takes up the lion's share of it, whereas only around 23% of overall instrument utilization is self-service, where people are training the users to run samples themselves, either billing them on a per sample basis in the dark blue, or on the per hour basis in the light blue. And there's a few who strike out on a different way and use what we're bracketing here as other modes of access, and this can range into different areas, but certainly for one facility that seemed to be a basically 100% subsidized, free for anyone within their institute way of operating, which certainly lightens the admin load for that facility. All right, so the last part I'm going to cover for today is the revenue side of things. And so we asked people for their direct costs, how much was covered by different areas. And the largest single one, in the green shading here, is 42% of direct costs were covered by a host subsidy, with around 36% of revenue coming from user fees. So it's interesting how that varies from quite a small percentage in some facilities up to 100% in other facilities, in several other facilities. There's a few where things like state or federal grants are used to cover the running costs of the facility, or they're bringing in host subsidy, not host subsidy, the other sources of funding, sorry. So if we look at this revenue overall per facility, it's a sort of recurring theme where we look at just at it facility by facility, there's a huge range in income being reported. And we had 24 facilities responding to that question, with the average amount being reported at just over $234,000 per year per facility. So interestingly, does this scale with the size of the facility? And the best correlation you can actually get is between revenue and staffing levels. I think someone mentioned this during one of the group discussions. And the largest single dictator of output is staff. More staff you have, the more output you're going to get. And this also correlates with revenue. And the average revenue that you get per staffing member is around $50,000, as reported in this survey. So just to summarize at this stage, the 2022 provides a great snapshot. And as I say, the personalized report, so you can benchmark where you sit on the landscape, will be coming out soon. And the other interesting question is, now that we've done this survey several times, the changes that we see each year are relatively small. And so what we're going to be doing is sending around a very short survey after this meeting, partly to get feedback on the meeting and on the sample testing initiative. But we'll be asking whether, do you feel it needs to be done annually, or should we lighten the workload and do it on a biannual basis, say, because there's always a balance between the depth of coverage, but also the ease of information, because it can take a long time to pull together the information for that. So without any further ado, I'll open it up for questions.
Awesome, Ben. Any questions from the audience? Well, actually, I do have one question. I mean, there are quite a few diagrams where it's always like says other. Do we ask for these people like what they mean by other, or is it just unspecified what other means?
Yeah. So I didn't have time to kind of put the others in on every slide, but yeah, we do. There's always a text box, free text field. And then typically what we do, there's a common other in the next year's survey that then becomes an option that people can just click. So we always, in theory, will minimize the others, but it's a great way, particularly in the software field, there's always new packages coming up. And then, Diane's a classic example of that, where the first year that was another. And now it's, the fourth most popular package.
So, and just a subsequent question, with the revenue, so you're saying per facility is roughly 230,000, right? So what exactly is this revenue? Is it just user fees, or is it all the grants, everything that goes in, or is it purely the user fees? Can you just talk about that?
A good question. I do wonder sometimes what people report. And there's certainly a few of you here today that I've been emailing in the last week, just trying to clarify, because occasionally people will put in 110, and they obviously generally mean $110,000. So it's there's increasing footnotes within the survey to try and clarify and define, so everyone's thinking in the same way as to what are we actually asking. But yeah, in that one, it's basically gets dictated as money you've got in the door from somewhere.
Yeah, right.
So yeah, it's hard, because often people will look at the question and read it one way, and then when I'm going through the answers, you're like, oh, hang on, why is that one completely different from everyone else?
I had a question, Ben. You mentioned at the start the number of facilities that responded to the survey, and I guess I don't know how other people feel, but would it be possible to sort of collate a list of contributing facilities, like even who attended this meeting, to have an understanding of other people in similar situations that manage facilities around Australia? Because I actually don't know. I'm not very familiar with everybody's that's participating, but it would be nice to make more formal connections with people.
Yeah.
Especially in the context where we are all individually going through similar processes in the context of, say, professional development, or responding to internal pressures for cost recovery and things like that. Yeah.
No, I mean, that's the whole driver behind these meetings, is because we're all facing very similar challenges, that if we can share that insight, and not everything works for everyone, but it's amazing how, on days like today, you just go, wow, that's a really neat idea. I'm going to have to try that and see how it pans out. So I don't want to make promises I can't fulfill, but we do have a nearly live website up and running, and the aim of that is partly, we've been talking about it for a couple of years now, but the surveys, not the survey, the multi-center testing's forced our hand, so we need somewhere to host that. And then we'll be trying to add information and functionality to that, and certainly one of the bits will be yeah, as you say, putting a list of who's who, as it were, and we can, because it's kind of interesting how we've grown organically. So there's not like, basically anyone who turns up to the meeting, we count as being in the group. But yeah, we might send out you're listed, and if you object, then we'll take you off. But yeah, it's great to have those kind of contacts and find out who's locally helping in that area.
Yeah, Joel is also suggesting in the chat whether we should start an APRF-like forum.
Yeah. And the other bit I would also say is we're always looking, if you've got a good idea, just drop us a line and we'll let you run with it, sort of thing. It's definitely a by the core facility staff for the core facility staff space. So if you have an idea what to do, and I would also say, obviously, we're looking ahead to the 2024 meeting. So if you have any topics for that you think would make a good theme for a session, we're all ears.
Oh yeah, I mean, let me just emphasize this, like, I know Ben and I, have been driving this for the last couple of years, but, this is a community effort. So, if you have, exactly as Ben said, if you, want us to cover any topics, or, if you think this could be an interesting speaker and might, just let us know. We will try to organize that.
One comment I'd like to make, Ben, about you mentioned the numbers have sort of stabilized. You're not seeing dramatic changes. Should we continue? One thing I would advocate is to keep in mind that for longitudinal studies, you don't know the value until it suddenly becomes apparent. So I would say keep it up. I used to work at an institute in the UK that had 160-year-old agricultural experiments, and they were nearly cancelled in the 70s due to lack of interest, but they kept them on and they became really fundamental climate change evidence. And that's like an extreme example, but I just say, just because it's sort of the same, that doesn't mean it's not very valuable. And if there is a big change in the sector, your survey will pick it up, and could be the warning sign, or a sign of good times, or capability shortages. It will come out in your survey.
Excellent.
Hey, any more questions for Ben, or general comments? Okay, if not, then look, I think this concludes the meeting. So thanks so much, everyone, for attending. I hope you found it useful. And yeah, Ben, anything to add?
No, that's everything. I think thanks everyone for coming along, and hopefully catch up with many of you at Lawn if you're down there. And yeah, we look forward to continuing the conversation via websites, and I'm sure we'll all be poring over the data as soon as it's uploaded.
All right, okay. Thanks, everyone. Have a good one, and see you in Lawn, most of you. Bye-bye.
Thanks.
See
Bye.
you. Bye.
Thank you.
This is where we can spot who's hanging around and gone off to go and get a cup of coffee already.
Yeah, exactly right.
I think that went well.
Yeah, I thought so too.
Agreed. It went very well, I think. I think everybody very much wants to see their data.
Yeah. No, I mean, I was, because I kept my eye a little bit on the participants, right? I mean, because in previous meetings, like as soon as we went to a breakout room, it dropped down half, and then, it came back up. But they
stuck around this year.
Yeah, we rarely had less than 60 people online.
Yeah.
I
almost stayed to the bitter end.
Yeah.
Apologies as well for cutting into anyone who was talking while I was recorded, and it's like
it's impossible to do the button at the same time.